This video will show you the basic steps involved in completing a carbon fiber wrap repair using ARC CFW. If the repair area involves a defect, ensure the defect is centered in the wrap region. Prepare the repair zone prior to applying the fairing compound. Each repair kit of ARC CFW includes the following: 2 250-gram kits of ARC 858 fairing compound, 1 12-inch by 3.5-foot length of glass fiber mat, 1 12-inch by 19.5-foot length of carbon fiber mat, 1 kit comprised of Part A and B of either CR or HT saturant, sufficient to prime the repair area as well as saturate the glass and carbon fiber lengths. ARC 858 fairing compound comes in a self-contained 250-gram pouch package. It is a paste-grade coating used to smooth over weld deformities, fill pits, and smooth over surface irregularities, which would otherwise compromise the structural integrity of the carbon fiber wrap repair. Dispense the Part A and B components onto a mixing board and mix in a figure-8 motion until the product is homogeneous and free of color streaks. Once mixed, apply ARC 858 with a stiff bristle brush or plastic applicator tool, filling in pits and any surface irregularity that may result in an air pocket under the carbon fiber wrap layers. When applying 858, avoid entrapping air by applying at thicknesses greater than 1/4 inch in a single coat. While the fairing compound is gelling, measure the pipe diameter to determine lengths of carbon fiber to be used. Each piece of carbon fiber should be long enough to encircle the pipe diameter, plus 6 inches. Remove the paper core from the carbon fiber roll and set aside for later use. Roll out the carbon fiber to required length and pull a strand from the cut area to demark the cut zone. Using shears, cut the fiber along the marked area, loosely roll up and set aside in a clean area. These will be impregnated with saturant in the next stage. Chesterton recommends a minimum of 4 wrap layers whenever a corrosion mechanism has been identified as causing wall thinning. After selecting the appropriate saturant, either CFW-CR or CFW-HT, add all of Part B to Part A and mix thoroughly for 2 to 3 minutes, periodically scraping sidewalls and the bottom of the Part A container. Using a tight nap non-linting roller or brush, apply a thin layer 200 to 300 microns, 8 to 12 mils of saturant as a primer for the surface to be repaired. To apply saturant, you will need a non-porous surface such as plastic-wrapped plywood, vinyl counters, or sheet HDPE plastic. This will ensure effective and efficient saturation. Unroll the pre-cut length of carbon fiber and pour a 2 to 4 inch bead of resin onto it. Using the plastic applicator, spread the resin onto the fiber, lightly pressing resin into the mesh. Remove the excess saturant from the fiber. When one side is saturated, lift the fiber length and place wetted side down onto the table. Saturate the other side using the same process. When both sides of the fiber are saturated, roll the saturated fiber length back onto the core that was removed from the carbon fiber package. Starting at the top of the pipe, center the wrap over the repair zone and unroll the fiber onto the faired and primed surface, applying light tension to the fiber as it unrolls onto the pipe. As the roll unwinds, use gloved hands to ensure the wrap stays centered over the repair area. As each wrap layer is applied, gloved hands should be used to smooth the fiber surface over the pipe OD and force any entrapped air pockets out from under the wrap. Only work the smoothing motion in the direction the wrap was installed. Successive wrap layers should be spaced between 30 to 45 minutes apart to allow initial setting of the previous layer prior to applying successive ones. If a more chemical S-Series or abrasion-resistant BX-MX top coat is desired, allow the final wrap layer to set for 30 to 45 minutes before mixing and applying at recommended thickness. The top coat should extend beyond the wrap region by at least 1 inch, 2.5 centimeters on either side.